today's topic is about the machine learning process. So how do you actually take your idea, and is it machine learning is actually suitable for you? Because it's a buzzword, right? Everybody's talking about machine learning. Everybody is talking about how to do things, and AML is like a buzzword. It's like in the food industry, organic is a buzzword, and in the technology industry nowadays, AML is a buzzword. Is it really needed for a problem to be solved? Is it something really that we really need to do it? So let's take some time to understand it. So as Ambu said, I would not get into the details of it. I'll want to touch upon on the idea process, and then we'll go from there. Okay. So I'll turn off my video just to make sure that we have a better focus on this one. So now, quick agenda. What will you get out of this session? First, let's look at from a machine learning process, an overview of it from a business model point of view, and how do you do the data collection, processing, and what are the different stages do we have as part of this ML process is what we will actually get into, and all the way back, right? And then better understanding of how to apply and leverage these machine learning to it, and some examples of how AWS customers and Amazon.com is using. I'm going to do it slightly different this time, but just want to know that AWS is one place I've seen more. There is more machine learning happens in AWS than anywhere else. There are several customers whoever wants to do their machine learning to be happening to solve their real world problems are actually doing it on AWS, and there's more number of people than anywhere else. Okay, now what is our mission? Why? I mean, there has to be a reason, not just because we just providing the product doesn't mean it really makes sense. Unless you really feel at heart that strongly believe in something, you will not be able to do it good. So at AWS, our mission is to put the machine learning in the hands of every developer. That's always been our mission, and right, like the way that we practice or implement machine learning for our own retail Amazon.com or .in based products, and how customers are and customers are benefiting it. Similarly, we're also going to be using and reusing these ones so that even our own customers of AWS who would want to solve their own problem, whether it is about discovering some new conditions, medical conditions through a simple process, or simplifying something that would take about years and years to solve a problem. Can I just bring that down to 1 minute? Or can I give a better fans experience for a TV or a sports like a cricket or football or a baseball? Can I just give a more real-time analytics so that people can actually get more engaged? So something what technology can do today, can machine learning push that limit so that you get a better research results, or you get better outcome, or you get better prediction, or you get better of everything? The technology is always about pushing that boundary for you to be able to do it. And how does machine learning is going to be helping you in that is what my next 40 minutes job is to make you understand. So just to give you one more step in terms of the Amazon machine learning stack. At Amazon, we call it as a 3-layered machine learning stack. The bottom layer is called the ML framework and infrastructure layer. So this is for those folks who are expert machine learning and artificial intelligence, experts, researchers who can roll up the sleeves, write their own algorithms, write their own frameworks, and do their own fine tuning because they love that tinkering, they love that way of doing things in a very raw way. So you could do that at this layer. So because Amazon platform is all about the choice. So rather than me telling you pick this and use it, I would give you what you would want. So either you can actually, if you are a researcher or if you are someone that you can actually roll up the sleeves and want to do things, you can actually pretty much love this kind of a layer in this one here, which is you can bring your own tensor frameworks like TensorFlow, MXNet, PyTorch, or Chain, or any one of these frameworks or models can be brought in, and bring your own model, bring your own data set, and then do this. Okay, there are, for image recognition, you probably would like a Swan framework. For video streaming kind of analytics that through machine learning that you want to do, you probably would like another framework. Or if you're doing some financial transactions, you probably would like a different model that comes in a specific framework. So whichever way that you would want, you can always customize these. And at this layer, you would also find enormous choice of this, whether it's a GPUs or FPGAs or general compute at the highest computing level, so that you can use it and reduce the time it takes for you to train the data, tune the data, and make something more predictable one. That's something you can do at this layer. Okay. Now, once you but interestingly, if you look at the industry today, there are not that many data scientists and hardcore machine learning experts today in the industry. So what that means is that there are folks who are willing to do it. They have a great example, they have a great need, but just that they don't have enough experts to be able to leverage this capacity. So that's where AWS kind of said, okay, fine, then we have all these raw components that anyone can stitch and make things happen. Can I actually automate this layer, infrastructure layer, so that I'm going to simplify the whole process at the underlying part, and I'm going to just let the user wants to just focus only on his algorithm, only on his kind of model, only on this particular data set, so that overall time that he or she is going to be spending on it can be reduced. That's where this Amazon SageMaker, the middle tier, comes into play, which is not only for data scientists, but even for developers, who are keen and who's got really good at Python and R, and then some framework and some way to tune it, they can actually get started on SageMaker. You don't have to be a really expert, ML researcher or academic one. You can also, get started at this layer. Now, the topmost layer is called AI services. The reason why we say that is because, see, again, it's the same problem where, I need this particular thing to be evaluated. Let's say I wanted to build an attendance management system, and I just want to look at this person on the camera and recognize whether the same person as we intended is the right person, and then allow and open the door based on that facial recognition. For such a thing, do you really have to have a ML researcher or an academician or a developer, ML developer? May not be. Even if you're a simple, a strong programmer and you know how to call a few APIs, the AI service is really nothing but something that is already been pre-baked and ready to use service that you can simply call one Amazon recognition service and just compare two pictures to see whether they both look alike. Or you can just pass on one number plate and say whether this is really going to be, what's the number displayed on that particular number plate, or some of those things can be done with this. So it really simplifies it to a level where you can simply connect and then use this AI service as is, because all the data is trained, and it just that you just have to use it, and then you'll be able to get a better accuracy out of it. So those are three layers. We call it as a machine learning stack. Just to give you a summary, the top layer is for developers who have no knowledge or little knowledge about the machine learning. The second layer is for those who would want to just go one level deeper and still be able to bring your own data set and then train it and tune it and then bring your own algorithm, make more changes and make something easier. Don't have to do a lot of repetitive stuff, but you can just focus primarily on ML and nothing else. The bottom layer is really for those hardcore machine learning researchers and someone who really want to do the tinkering job and then understand more about the framework and do something really interesting at that layer is what you could do. Okay, so that's the machine learning stack. What's interesting is there are quite a few new changes came in between. I would not get into those right now, but do know that it's a continuously evolving machine learning stack based on the customer's feedback. We always improve these models. We introduce new AI services, for example, TextRact or a forecast or a personalized. These things came just a few months back. So these are all going to be helpful by the end to the end customers as well. Okay, so now how do I start, or where do I apply the machine learning? I think that's a basic question that everyone would have. Where can I apply it, and what kind of approach should I take? Okay, let me just take the typical process of machine learning. Okay, so we will not get into each of those each of those steps, but certainly something that we really wanted to, highlight this. Okay, so one, you really have to have a good business problem. Okay, the business problem is the idea that you have. Say, okay, is this business problem going to be solved only by machine learning, or can this be solved by anything else? Okay, in most cases, you probably can solve it in other means as well, which means it has to be solved by some way. Like, for example, if you are a doctor and if you're looking at an X-ray, okay, you can probably identify based on your experience, based on your eye details, you'll be able to find out about how this X-ray is, in what kind of condition that it has, and how can identify it. But if you are given, maybe you'll be able to do it for maybe 10 or 20 X-rays an hour at the max, even if you're an experienced doctor. But what if I give you 1,000? What if I give you 10,000? Would you be able to do it? If there are hospitals where which are specialized hospitals, but there are a number of patients who are coming in for a lot of help, but clearly there's not of skill not there. So how can you take the help of technology to be able to take it happen? So there are problems which can be solved by human effort, but can it be done much faster is the question. So that's where one possibility. There are some places where, okay, I have this weather forecast. Can I predict the weather in the next 10 days, next 2 days, next 5 days? The tsunami coming in, can I predict something in what could be the possible damage based on the pace at which it is coming in and the angle at which it is coming in? And can I just do it and warn the right people at the right time? All these are the business problem, and asking the right questions. This is where most people will take a very long time to realize whether or not we require the machine learning process or not. So understanding the business problem and coming up with something that is really logical and usable one is really important. Now, coming to that, how do I actually frame it? How can I convert into assuming that it is actually a machine learning qualifiable business problem, then how do you actually convert it? Like, what all things that do you require for machine learning to solve this problem? So you need to be able to see what kind of problem it is. Can this be solved by having multiple data sets? I just talked to you about X-ray. So do I need 100,000 X-rays for me to be able to train my model, for me to be able to say how to do this? Or does it require some kind of unsupervised learning for where I don't need a data set but still be able to make some predictions? Or it could be about something different. So all these things require or not required this kind of process where data collection, data integration, data preparation, cleaning. These things are really required there. So let's say if you wanted to identify human being by looking at the camera. So the machine learning model should understand whether what constitutes that particular picture. How can I say whether the particular person is actually a human being or not? Whether the person is laughing, and all these things we all know. There are a lot of several tools right now from every popular vendor who actually give you that. But how does this happen at the underlying? It's really all about the data collection, data integration, and data preparation and cleaning. This is a three-step process that happens in each of those. And interestingly, there are some areas where you actually going to spend a lot of time on it. We were going to talk about it. Okay, and then the next phase is really about once you have the right set of data, the last phase of the data preparation cleaning is where you're going to significantly turn, because getting data is not a big problem in India or anywhere across the world. You can get the data, but getting that data and cleaning it and making it ready in the right way so that you can actually be able to get the right analysis and put it into a right model is going to be a long process. So we'll get into that a little later. Okay, so but this purple boxes is really about what frameworks to be picked up, what algorithms to be picked up, how do you tune those models, and how do you do the parameter tuning so that you get a better accuracy of the data that you're kind of evaluating, and you get into the next one. So this is where the evaluation comes. Okay, I have the business problem. I'm actually picking up the right model. I'm doing this, collecting the data and cleansing it and integrating it, making sure that I'm putting this model. Then I'm going to ask the question, am I solving this business problem or not? So if it is not, then you can go back to the same and see if the data collection. So that the process itself is a very iterative process. You're going to spend a lot of time in kind of evaluating this process along. Okay, first time you may not get it, but the second time, third time, you're going to be fine tuning it to make it happen until you get a better accuracy. Even today, whether you're doing natural language understanding, NLU, or whether you're doing a facial match, or whether you're recognizing a number plate, everything will have some kind of an accuracy level. That means you could do to a 95 to 96%, not more. Okay, so 100% match is very rare. You can probably upload two same pictures, two copies of the same picture, you probably can get 100% match. But in general, when you're actually looking at a passport size photo versus somebody who's walking on the road and then comparing both, you'll always get the accuracy there. So this iteration, this tuning and modeling is really about getting that accuracy to much closer, so that you get a better accuracy rate in that. Okay, so once you get that right results, that yes, I think with this process now humanly possible results can come. Now this model can still look at the same X-ray and still be able to make a similar prediction like the way that the human doctor can do. Now, can I just take that problem into evaluate it and see if it's met, and then now I'll go into this actual predictions and model deployment in a large scale one. Okay, so again, I think this is the whole process that comes into play, where it is really about model framing. It's really about how do you define the problem in the machine learning, and that has all these step process, from data collection to applying the right model and then tuning it and model it and then debugging it and then applying it. So this is the continuous process that happens there. Okay, that's just a very high level. Now, how do you find the right ML problem? Okay, so I think for this one, what I'm going to do is I'm going to just touch upon Amazon.com or .in kind of an example. Take a look at this. There's if you look at, there is like 3 circles here. One, it talks about the Prime video. That means anything that I upload as part of the Prime will come under this box. I can just click on that the blue icon or the blue link there right below that first circle. I'll probably see entire Prime videos one. Similarly, the luggages section is on the second one and third one. So I may not be able to tag each one of them, but I probably just uploading them, and it is the backend way to be able to identify which one is similar to what. So whether if there's a garlic and there's a tomato, do they belong to one particular category? If there is a suitcase and there is a purse, do they belong to one category? How do you automate when there are millions of sellers across the globe are uploading and updating the content? If you are having this platform, how do you ensure that anything that has been uploaded is according to the standards and is according to the consistency that we're providing, so that an end user like you and me who's opening up and shopping on a portal, that I will not get confused and I should be able to see all these different categories one blocks. Okay, how do we do it? One way is, you can actually go into, as I said, if you are a machine learning expert, then you can just build your own model and then see how do you actually look at these commonalities and then categorize them automatically. Or what we have done is, because these are all very frequently one, whether this is for this or you take an example of LMS, learning management system. Now, if there is a student who is very keen on understanding about space, and he or she is just going through the space related videos or courses in that large learning management system. Now, does it make sense for you to be able to provide or LMS tool to provide what would be the next likelihood, the course that the person would be interested? Would it be nice to bring such things closer to his screen or her screen so that the possibility of getting into more deeper and better learning about the space is going to be good? It's really about bringing the relevance, like the way you as a teacher that going and talking to them, and if you see that the person is actually enthusiastic about a particular favorite subject, would you not want to give more and more information about it to encourage the particular student? Absolutely, right? So similarly, how can technology do a similar thing automatically without your intervention or somebody else human's intervention? Okay, so that problem is there in not just in the retail but education or any other industry. It is the common thing, which is really about bringing the relevance, bringing that thing that is required for a particular consumer, student, or a citizen, so that it can actually do it in a much better way. Okay, so interestingly, Amazon, what we are doing at the back end with those real-time personalization and recommendation, that what we are giving at that in that Amazon.in or .com, we're able to give that back to the same AWS. We said, okay, let's make this as a service and as an AI service, and whatever that we learn from our own millions of pictures and catalogs, can we at least give the service so that anybody else wants to build their own retail portal, would want to build their own LMS portal, would want to build their own, maybe healthcare application. Can we actually make it happen this way? So, which means you as a developer or a student who can actually exploring the ML and don't know ML much, you can simply use a service and see whether it can give you the result that you would want. You can actually experiment on it. There are good number of customers are actually using it today. For example, Domino's use this one based on how you as a user is ordering the pizza and what kind of pizza you like, what kind of toppings do you like. They would actually use this personalized to be able to see, okay, what would be the next interesting thing for them? Can I just send this email to them about these kind of ones? And I think that's one way of looking at it. Okay. Hopefully you're following me. So now the next question, next topic is, okay, if you look at any of these Amazon.in or .com kind of a page, you probably would see that top right or left corner, you see a circle where it says this product page was automatically translated. Was this translation helpful, yes or no? While I'm just looking at only, not just English, I think it's more about, it's a different language. I think it's about, I think it's German language. So, but it's about, and also if you look at this price as well, it's actually pound. So in UK. So based on where you're actually opening it up, it automatically detect it and translate it automatically. So this is, if you want to scale globally, if you want to scale much larger scale and still be able to have less effort to be able to make these things happen, the translation thing happen, it's much easier for you in it. So there is actually service for it. For example, there's a Translate is a service where you can do a real-time translation from one language to another language, from English United States to English UK or English India. All these you can actually do it in the way that you would want and in real time. That means if I'm opening the same page in a different language, it will automatically translate automatically. Okay, so you don't have to do anything. You don't have to do anything from your end. Translate will take care of the converting your English to a respective language. There are some supported set of languages now. They're going to be continuously be adding, but the beauty of converting it much faster with just a fraction of a second kind of removes that heavy lifting that you as a student or a professor or a developer or a startup don't have to put in that there. You can focus on your core idea. Okay, it's like a doctor is good at taking care of the patients or the conditions, may not be good at managing the technology. So let the technology piece be there on the something that that AWS or the cloud computing take care, while you can focus on the problem that you're solving, and you can simply use these services and make it faster. So it is another service which can really convert this into it. Okay, and one more, like a forecast is another AI service, a simple service a developer without having a knowledge of machine learning can use this, or a beginner can still use it to accurately forecast based on same technology what Amazon.com uses. Something like, okay, I've got these hand sanitizers that would be required in the upcoming week. Okay, the demand of hand sanitizers kind of exponentially increased in the last 1 month. But if you look at seasonal ones, this is a surge one, but the seasonal ones, which one of them required how much time. Let's say if it takes for me to be able to procure procure certain goods, maybe I'll just give it as an example of a soap, right? A soap, maybe for me to be able to get 5 more boxes of soaps cases would require a 2 weeks heads up notice. Okay, or how can I ensure that how much time that I need to keep the lead time when I have this retail where the products are kind of consuming, and how do I maintain, how much stock should I be maintaining, how the consumption happening, at what time, at what level, and so that I can accurately predict my demand, and I can accurately create the supply accordingly, so that I will not have a problem. So we kind of mastered this at the back end on how these products are going to be shelved in a particular fulfillment centers or in the respective places, so that the closest space is where you can actually faster delivery is possible. So all these things, that forecasting is really about helping out in identifying the demand generation and supply for that, and such scenarios can be helpful there. So this is another service which was used at Amazon.com. Now it is available for everyone else to use for their own experimentation or for the usage. So not only that, there are, interestingly, there are several services like those, text translate and forecast and personalize. Amazon Poly is one. Amazon Poly and transcribe and translate, all these are different AI services, very easy. You can combine these and you can actually build your own contact center without you actually doing anything on a machine learning or data training or anything. You can just combine all these 4 or 5 machine learning ones and add your own program language, create your own nice user interface, and can listen to the folks who are calling you, can take those audio transcripts and then convert them into a text transcription by transcribing them, and translate them into a different language if you are presenting it to a Spanish or different language. And you can also do a sentiment analysis by applying a comprehend as a service to see how, whether the customer who called me through the contact center, is he or she is like very anxious, or was he disappointed, or was very happy. Can you actually make some kind of sentiment analysis based on those? And all these things, you can also build a chat bot where you can automatically have some automatic responses back there. All these things are actually possible with these services that it happens there. In fact, OneEdge, one of those SIP-based voice calling, voice over IP, they actually use the contact center. Liberty Mutual is an underwriting company, they use it. American Heart Association use this for their contact center. They can actually build on those ones. So it kind of, these AI services actually improve the customer experience, through humanly kind of a voice, and then with the high degrees of accuracy. And these call logs can be transcribed and analyzed, and continuous improvement can be done. This is all great stuff that you could do with these. All right, so now let's take one step back and just see how we could look at this, collecting the training data. Okay, how do we collect the training data here? Okay, what all things is possible as part of this training data? How do you collect it? How do you integrate? How do you prepare? I'll just give you a very high level picture of it. you know, so just say, these are left hand side. What you have is really about, there are different sources where you get the data. Like for example, if I'm a manufacturing industry and I want to get something really about these machinery that I'm using, how effectively they're functioning, and if I want to get to know more about it, my industry, I can get these IoT devices, I can get the data from this IoT. That could be one possibility. Or it could be about my mobile devices, like for example, those healthcare apps which are kind of coming up recently, really focusing about pushing the data to you, and are they delivered to you? Are you actioning on them? Or there could be apps which are coming in to see, are you actually close to a red zone or a yellow zone, or these hot spots? Can you just look at how close are you there? And if you are quarantined, are you actually moving out of your quarantine zone? All these things, something that these apps are going to be help you do it. So you can cut the data from these and be able to accurately and or probably in a relevant way can update you so that you can take action on it. Or it could be a classic data which is sitting in some kind of a ERP or RDBMS system somewhere where you can just pull this data. Or you may have some thousands of millions of PDF files lying there, and you want to get the data from there. So the data source can be anything. It can be from your Facebook, Twitter, Instagram, or your manufacturing kind of data or hospital data coming from those devices through IoT or through other human surveys, or this static. So it could be a structured data, it could be unstructured data, it could be a video streaming, or it could be audio streaming. It could be about just bulk data coming from, say, your stock market, old, maybe 3-4 years old data to do a historical analysis, coming in like some 1 petabyte of data to you to be able. So whichever format, depending on what problem that you have, you can pick the source from this left-hand side and get them in either real time or in a bulk import batch wise and dumping it. So, and then you create this data lake. The data lake is nothing but a combination of these different sources of data that is coming in, and be able to use this for my processing or ETL processing, or applying this machine learning and do it. And based on this data lake that I create, combination of the structured and unstructured data, then I'm going to be using different models and different mechanisms to be able to pull this data and apply it and pull and create those applications. Okay, that's how the whole data collection is going to work. And this data that I'm getting it from each of those, I may have to anonymize the data because I want to make sure that there is no personally identifiable data when I'm doing this whole processing in it. How do you do that? Those are all things can happen multiple ways. Okay, so as I said, this data collection includes the several tools can be used, like IoT Core, or some of the real-time streaming, or some of those bulk data that you're shipping from one place to another. You can use different tools. I will not get into the tools part right now, but these tools will help you to be able to dump all the data, collect all the data, and then use those machine learning based services like SageMaker, Recognition, Comprehend, or maybe if there is a big data kind of one, you can use the Hadoop, Athena, and EMR to be able to make something useful out of this data. Okay, now the next one is about the supervised learning. The supervised learning is nothing but you have some data that where you wanted to be able to get some outcome done. So you have data labels, data and labels over here. So data is actually cheap. For example, you can easily get the data, but the data is not going to be labeled all the time. So for example, I have these two pictures over here, and you don't even know what this picture really about. Okay, is it really about animals or any of those? You can get this from machine learning, but there are a few things where you really have to do a labeling for these. That takes a humongous amount of time there. Okay, so doing the labeling is actually going to be a very expensive effort. So let's say if I'm focusing on some problem which I'm solving, where I need a collection of images, collection of PDF files and something else. I think we really need to be able to make this, labels part is very, very tough one there. So, for example, we do have something called the mechanical Turk, which kind of helps you in labeling the data, because that's where customers are spending significant amount of time, before getting them into a data sets or training sets. So in Amazon SageMaker, we use this something called as a ground truth. Basically, the ground truth will help you automate this data labeling process much, much better. So that the percentage of which the human intervention is required to label the data is significantly reduced. So that's a humongous help there, where if you can at least save costs on this human or this data labeling cost, that significantly helps you in a lot of these stages. Now, the next part is that create, train, and deploy ML models. Basically, it is about taking those models, sort of data that is coming in there, and picking up the right framework, picking up the right model, picking the right algorithm there, applying this data and tuning them, and testing it, engineer it to see whether it's able to resolve the issue, and then can this model work for these things, iterate it more and more, once again, second time, third time, 10 times. Or if you're doing, let's say, autonomous car as an example. So is my autonomous car is able to, accurately detect or drive or see those bumps, and then is it able to learn on itself? It's called reinforcement learning. Or is it able to learn on itself based on those new learnings which came across and then change itself? All these things are possible with those modeling on that. So the machine learning process, from a technical view, if you look at it, it's about collecting and preparing your training data, like labeling and cleansing and integrating all this data, collecting all this data which is coming in a structured and non-structured way. Choose your and optimize your ML algorithm, because you cannot just simply plug and play there. How do you actually choose this? And set up the environment, manage the environment for training, because you really need to train that. Train and tune. Basically, it's about trial and error basis that you do. And once you get to a stage, this 4-step phase is like a very continuous phase. Once you get into this 4-step phase, where you can actually deploy it to a model production fast, and then you can scale it much faster. So there are, in fact, I think if you double click on it, there are 2-3 steps are actually very iterative. But I think this is a continuous iterative process for you to be able to happen. This is somebody who wants to do it at the back end on their own using SageMaker. This is what you're going to be spending significantly on it. But there could be a lot of generic problems where you can probably straight away use those AI services which I told you about, this Amazon Comprehend, Amazon Forecast, Amazon Personalize. Those things can help you straight away. But this Amazon SageMaker can be used for something unique, where these AI services, already trained, pre-baked services, not going to address your problem, is where you're going to come to and then do these things for you. So these are the standard models that anyone can do. But if you look at SageMaker, it takes away this entire process of this first 3 steps can be taken away very easily, and with those pre-built notebooks, the Juniper notebooks, and then have these pre-baked algorithms available and the frameworks available. You can simply use all these so that your time for your idea to experiment is going to be significantly reduced with the SageMaker. Okay, so just a few steps here which I want to just talk about. So just to summarize, I think this is really about focusing on what is what is the problem that I have and how do you solve the problem. But if you look back, there are some services which are available where the data sets are already trained based on our own learnings with the way that we've been interacting and collecting the data, and based on those, it will help those end customers to be able to make it much faster and easier. And there are other academicians and who would want to do it, absolutely can do it. You can pick those GPUs or NVIDIA based GPUs that if you want to experiment on, or if you wanted to just try those compute with Intel Skylake processor, then we can experiment with those and train your own model and testing them all there as part of it. Okay, so some of you are probably part of AWS Syndicate program. AWS Syndicate kind of introduced at a very high level about this machine learning and Amazon machine learning stack. But it is all up to your imagination what you could do. There are great examples of how you can actually use this. There are good number of customers who are using machine learning on AWS today and solving some very interesting problems. In fact, for this COVID-19 kind of situation, there are actually some data sets which are actually available as an open data. Someone like you is going to be doing a research. You can actually use in this open data and leverage this with your cloud research program and experiment and see if you can actually solve something that the entire world needs. Who knows? That could be one of you as well here. So there are several frameworks there. You can pick one that you would like to have. MXNet could be one. 1 second, I'm just going to show it here. So here are some of the frameworks here: Apache MXNet, TensorFlow, Caffe2, CNK. These are all the different frameworks. You can pick any one of them. They're all open source. You can play around and get it done.
Okay. But is there any use cases or is there any examples that you can talk on ML process in healthcare and agriculture?
Okay, so in the healthcare, there was one example I was talking in one of the XICTACADEMY session where there are a number of ones, but there's one that I talked about earlier was there was a development where based on a retina-based picture, a humanly possible doctor can actually look at and see is there any complication that I can detect for early signs of diabetes just by looking at the retina-based picture. And with machine learning, you can actually do it much faster, and easier. And there could be other healthcare problems as well. I just talked to you about where if you wanted to find out within currently in the current scenario, in the healthcare scenario, there are n number of use cases where people are talking about how can I issue those e-passes, or how can I ensure that I warn a person who's not going very close to the red zone, or who's actually not willing to, or not supposed to be moving out of quarantine zone but still moving out for XYZ reasons. How can you ensure all this? There are so many types of healthcare kind of questions come up. You can absolutely think of different ideas and see how machine learning can help there in those lines. And there are enormous ones. You can actually look at our aws.amazon.com site for customer references on how some of the healthcare customers are using them today.
Okay. So is there any ML tools available for free? Someone is asking this question.
So the frameworks which are available, those are free. Those are open source. You're free to use them. But when you are going to be using it, and you obviously a lot of that compute to be able to experiment and do it. Are they there? Yes, absolutely. You can just pick up your own laptop and then pick one of these open source frameworks and take the data and do it on your own. Okay, but if you want to do it on AWS, then you probably have to think about using it. You use the compute, and for that there could be charge. But if you're part of the AWS Syndicate program, the students will already have that process already in that.
Okay. So that was leading to my next question. You were speaking about some of the free data sets and all. Is it available part of Educate, or is it elsewhere?
It is public. It is public. In fact, on my LinkedIn, I just chose that, or maybe in AWS link, it is out there. There are some open data sets are available. You can really take a look at it that we collected from like a lot of these John Hopkins University and other well-known bodies, healthcare bodies are actually sharing this data publicly so that the researchers can actually look at them and do some meaningful about it.
Maybe they can just Google out saying AWS free data sets. Will they get it?
Open data sets, yeah. Open data sets probably could be the way to do it.
Okay, I think you will have to put AWS, Amazon open data sets, public data sets. You may surely get it. I think there are a few more questions which looks more technical. I think that those questions we will route it to you. You can answer offline, because I just want to know, as you said, we don't want to take more of your time. What language can be used for machine learning? No, should we answer that question?
So, yeah, before I answer it, let me just answer this question about, I don't know whether you can see this screen.
Yes, we can.
Can you see it? Okay, so basically this is the one that I was referring to. You can actually, this is the public data lake for analysis of COVID-19. Take a look at this and you probably can get some information about it. Okay, this is coming from John Hopkins.
Okay, so you should know it's related to COVID. Okay.
Absolutely. So similarly, there are a lot of open data, registry out there, not only for the COVID stuff related one, but there are several open data registry out there that people can actually get into, are available. Do take a look at the spatial data out there as well on that. So wish you all the best for that on those.